Okay, so this is example 2 in summarising data, and we're looking at class boundaries and midpoints. So for group data, it's really important that we understand the notation that's being used in terms of representing the intervals. And it tends to come in 3 different ways. We've got 3 examples to look at here. The first one uses this inequality notation. The lower symbol means that 0 is not included in the first interval, and we're looking for anything bigger than 0. The top one means that 5 is included in this first interval. We're looking for lengths, presumably, because this is the letter L, that are bigger than 0, not including 0, and that are less than 5 or equal to 5. Similarly, moving down, 10 is not included in this interval, but we're looking for lengths that are bigger than 10 and up to and including 15. So, what is the lower class boundary? Well, even though 0 isn't included, we still call it the boundary to that interval. Similarly, we put here a boundary of 5. 5 is actually included in the first interval, but 5 is the cut-off point between the 2 intervals. 10 is the top value here, and it's not included here, but it is still the cut-off point between the 2 intervals. Similarly, we've got 15 there, 20 there, and 60 here at the bottom. Upper class boundary, well, it's a little bit easier here because these are all included. So 5's the top boundary there, the upper boundary, then 10, 15, 20, 60, and 70. Okay. We've got the frequencies here. This is how many things occur in each interval. So there are 4 values between 0 and 5. There are 15 values between 5 and 10, and so on. Very often we want to know the midpoints, for example, when we're calculating the mean. So, what is the midpoint? Well, the end values are 0 and 5. So although 0 isn't included, everything all the way down to 0.000001 is included. And so we're getting infinitely close to 0. So we actually do call the midpoint 2.5. And I did that by adding together 0 and 5 and halving it. Halfway between 5 and 10 is obviously 7.5. Halfway between 10 and 15 is 12.5. 15 to 20 is 17.5. 20 to 60, if you get a bit stuck, add them together and half it. 20 add 60 is 80. Half it is 40. And halfway between 60 and 70, I think we can work that one out, can't we, is 65. So that's how you would do it if it's inequality notation. Moving on to the next one, we've got an example here where it says 30 to 31, 32 to 33. There's a gap here. Remember on that last one, these two numbers are the same. They're not now. These end numbers are not the same. And this is the type of example where we go a half out each side to fill the gap. When we have continuous data or we group data like this, we can't have gaps in between. So let's have a look at this 32 to 33. We know that the previous interval finished at 31. This one doesn't start till 32. So the lower boundary here we call 31.5, and that would be the upper boundary of this one. Similarly, 33 and 34, we'd go halfway out, so that'd be 33.5, and this one here would be 34.5. Same again, 36 and 37, halfway out because there's a gap. What do we do with the ends then? Well, we follow the same convention, so 39, the next one would start at 40 if there was another interval. So we call it 39.5, and if there was an interval before this one, it would go up to 29. So we have 29.5. Now with the midpoints, you can either use these, or because we've gone half out, you could use these two, the upper and lower class boundary. So whichever you use, halfway between 30 and 31, or halfway between 29.5 and 31.5, whichever you want to do, halfway between them is 30.5. I tend to use this because it's a little bit easier to work them out. So halfway between 32 and 33 is 32.5. Halfway between 34 and 36 is obviously 35, and halfway between 37 and 39 is 38. But like I say, you can use this value and this value, and you'll get the same answer. So that's when you've got gaps in between them. And then this last one is very weird. 0 to what? Well, it doesn't tell us, so it means 0 up to anything that doesn't fall in the next interval. So it means 0 up to 9.999999 recurring. Same as on the first example, lower class boundary is 0. The upper class boundary is 10 because the next interval starts at 10, so that's the cut-off point between the two. The upper boundary here will be 25 because if you look on the next row, this interval starts at 25, and the upper boundary here will be 40 because if you look on the next row, this one starts at 40. And conveniently, they've told us the upper boundary of this one, otherwise we wouldn't know what to put. Midpoints, well, halfway between 0 and 10 is 5. Halfway between 10 and 25. Again, if you're not too sure, add them together and half it. Same for this one, they add up to 65, so it's 32.5. And the last one, 40 adds 60 is 100, and halfway between them is 50. Those examples, the first two, are in the S1 textbook, so you can have a look at those again in there. The last one isn't in the textbook, but you can always watch it through again if you're not sure. And there's a nice exercise here to practice as well.